Okay, so let's take care of the questions. So we're going to start with number 9. All right. So number 9 says, problems 9 through 10, evaluate each expression using the graphs of f of x and g of x shown in the picture. All right, so I'm going to put my book down here so I can kind of point. Not that it's very big on your screen, but you have your book, right? So 9a says g of f of -1. Now we know what that means, right? That means g of f of -1, right? That's the definition of the composition. So we come over to our graph and we start with f because that's our inside function. F is the absolute value looking kind of graph, right? Because it's got a corner. Now I need f of -1, and f of -1 is 1. There's a dot on the graph at -1, 1. So I evaluate f of -1 by looking at the graph, and then that means I have to find g of 1. So now I go to the graph for g, and I'm not looking for g of -1, I'm looking for g of 1. So when I go to 1 on the graph of g, the point there is 1, 4. So this turns out to be 4. All right. And that's how you do it with a graph. That's how we find a composition with a graph. So let's do part B. Part B says g of f of 0, g composed with f of 0, which is going to be g of f of 0. Right? It helps if we write it out. And now what is that going to give me? Well, I go to my graph for f, right? I go to my graph for f and I look at 0. Now, the graph of f goes through the origin. They didn't label it, but it goes through the origin. So we're supposed to know that's 0, 0. So f of 0, right, is 0. So this turns out to be g of 0. And then if I go up to the graph of g, the graph of g is the curvy one, g of 0 turns out to be 5. So I get 5 for that one. And then if I do c, c is f of g of -1. Now we know what that means. That means I find f of g of -1. Now I have to find g of -1. So now I start on the curvy graph, and at -1, g returns 3 because it goes through the point 1, 3. Sorry, -1, 3. So that becomes f of 3. And now I use my graph of f and I look up 3, and f of 3, they don't have a dot there, right? They don't have a dot on 3 for f, but we're supposed to be able to figure it out because, you know, they have the red arrow kind of pointing right there. So that turns out to be f of 3 turns out to be -1. Just because it's halfway between the dot at -2 and the 0. That's how I knew it was -1. And then D is f of g of 4. So we have f of g of 4. So I have to first find g of 4. So I go into the g graph. That's a curvy one. G of 4 is 2. And it goes through the point 4, 2. So this becomes f of 2. And then I go on the f graph, and f of 2 is -2. Okay, so they're teaching us how to find the composition with a graph instead of with, you know, the formulas. Now, so that takes care of number 9. The next one on the list is 25. Okay, so what's going on 25? Well, on problems 21 through 28, it says find the domain of the function. So 25, I have to find the domain of the composite function. So in 25, I have f of x equals the square root of x, and I have g of x equals 2x plus 3. Okay, so those are my two functions, and they want me to find the composition of the domain of f composed with g. So that's f of g of x. Now our steps, right? Step one was to find the domain of g, because that's my inside function. So I do that first. So I look at g and I ask myself, does g have any issues? Is there any problems? G is a polynomial. Polynomials have a domain of all the reals. We wrote that on our library of functions. So the domain here, the domain of g is a set of x's such that x is an element of the reals. So I don't have to do anything there. There's nothing I have to worry about. I don't have to eliminate anybody. Everybody's included. Now our second step, that's our step. Right here we have to ponder. We have to think. And I told you that you begin with the question, right? You begin with the question, does f have any issues? That's where we begin. And so we look at f. F is the square root of x. So f cannot accept any negative numbers, right? Because we can't take the square root of negatives, because there's no complex numbers when we talk about domains of functions. So f can't take any negatives, which means g of x must be positive or 0. Because remember, f doesn't get an x, right? X doesn't make it to f. G of x makes it to f, right? We drew that picture in our notes like this, and we said this is g, this is f. This is the order they go in because g's on the inside. And we said x goes there. That's where x goes. It goes into g. But once it lands in g, it's not x anymore, because now we've multiplied it by 2 and we've added 3. So it's not the same number anymore. We changed it, right? If 5 lands in here, 5 times 2 is 10, plus 3, 13. 5 turns into 13. That is what goes into here. G of x goes into f. So when we get into this statement down here, we look for any problems for f. And then we say g of x has to satisfy those conditions. G of x has to satisfy those conditions. Now, yesterday, or Monday, we said it can't equal something, right? But when we're doing inequalities, because this says f cannot accept any negatives. Well, we don't write things like this, right? We don't write things like this. F cannot be negative. We don't write that. We just say it's got to be positive or 0, right? Not negative isn't a symbol that we use. Not equal, that's a symbol we use in math. This isn't the symbol we use. We just go the other way. So g of x, which is what lands in f, g of x has to be greater than or equal to 0. Now, what does that mean? Well, we know what g of x is. That means 2x plus 3 has to be greater than or equal to 0. Or 2x has to be greater than or equal to negative 3. Or x has to be greater than or equal to negative 3/2. Now we put them together, right? That's our last step, right? Our last step is to put together what we said here and what we said here. Now up here, we didn't eliminate anybody. So all we have to focus on is this. All we have to focus on is this. So our domain of f composed with g is going to be, we don't get any restrictions from step one. It's going to be those x's so that x is greater than or equal to -3/2. And if we follow these steps, we'll get these problems right every single time. Every single time. And if you watch a video on the internet, everybody does it like this. It's the way I told you, Stuart, our calculus book next year, right, that we'll be studying calculus from, it does it just like this. It's the only way to do it. So 25 was to find the domain. Notice we didn't find f composed with g, right? We don't care. It's not important. It's not part of the problem. You don't need it to answer the question. So why go find it? You're just doing extra work. So that takes care of 25. Okay. What about 33? Because that's an exponential list, right? What about 33? Well, if we clear some space here, right? Running out of whiteboard cleaner. Okay, I bought a whole case from Amazon, so I have more. So on 33, right, on 33, what are the instructions on 33 say? It says, find the domain of each composition after you find each one of these parts, right? After you find each one of these parts. And they want part A, they want F composed with G, part B, they want G composed with F, then part C, they want F composed with F, and part D, they want G composed with G, right? So we got to do three things for problem 33. Plus, we got to find the domain of each one of those, right? The domain of each one of those. So in problem 33, they give us two functions, of course. They give us f of x equals x squared. And they give us g of x equals x squared plus 4. Those are our functions. So part A, right? If we were just going to do part A is f composed with g. That's what they want us to find. Okay. Now we know what that means. It means this. So F says, right, whatever you put in here, you're going to square. Now, personally, I like to warm up, right? I like to, when I'm going to do this right here, I like to warm up. So I go off to, some scratch paper area, and I go, okay, what's f of 2? It's 2 squared, that's 4. What's f of 7? That's 7 squared, that's 49. What's f of b? B squared. Okay, now I'm warmed up. So what's f of g? G squared. See, I warm up over here with a 2 and then a 7 and then a letter, and then I jump right into G, because that way I don't get confused. Because I've trained my brain over here, and now there you go. Now we know what G is, right? We know what G is. G is x squared plus 4. So they want us to square that. Now we get x to the 4th plus 8x squared plus 16. So that's f composed with g. They also want me to find the domain of that, right? Now, I don't use this to find the domain. Remember, sometimes that gives me the wrong answer. Sometimes it gives me the right answer. Sometimes it gives me the wrong answer. So we just do it this way, so we always get the right answer, right? So if I'm going to find the domain, I start with step 1. I find the domain of g. G is a polynomial, so the domain of G is a set of x's such that x is a real. And there's nothing we can't square. There's nothing we can't add 4 to. Then we do step 2. That's our step. We start with, does F have any issues? That's our first question, just like right here. Does F have any issues? And we look at F and we're like, no, F doesn't have any issues at all. But if F has no issues, that means G of X can be anything. Right? The domain of F is all the reals. That's what we mean when we say F has no issues. We mean the domain of this is all the reals. Well, then there's no problems here and there's no problems here. So the domain of F composed with G is the set of X's such that X is an element of the reals. Because we don't have any issues. There's no problems with step 1. There's no problems with step 2. Or in terms of our picture, right? Here's G of X. Here's F of X. X goes in here, right? X goes in here. And anybody can go in. Anyone can go in there. Now, G of X goes here, right? G of X goes here. But F says, I accept anybody. My domain is all the reals too. So anybody can go here. So our domain is all the reals. Okay. So that's how you do F composed with G. Now I'm not going to do all 4 parts, but I'll do G composed with G here.
Mr. Rainier?
Yeah.
How did you get 8x squared?
I foiled that. Right? Because when we square it, we FOIL it. So
can you like write it out?
Yeah, I'm going to in the
Okay.
corner right here. Because this is what it means when we square it, right? And then this times this gave me my x to the 4th. This times this gave me 4x squareds. This one times this one, 4 more x squareds. This one times this one is my 16.
Okay, thank you.
You're welcome. You're welcome. So let's do part D. We'll do G composed with G, right? That's what they want us to do in part D. Now, what does that mean? We know G composed with G of X means G of X, like that. Now, I like to warm up. G of 1 is 1 squared plus 4, that's 5. G of 7 is 7 squared plus 4, that's 53. G of B is B squared plus 4, that's B squared plus 4. So G of G is going to be G squared plus 4. Because that's what G says to do. Now, that means I'm going to take x squared plus 4, that's G. I'm going to square that, and I'm going to add 4. So we just did that right here, right? We know what x squared plus 4 is. So this turns out to be x squared plus 8x to the 4th plus 8x squared plus 16, right, from here. But now I have another 4. So we get x to the 4th plus 8x squared plus 20. Plus 20. Now they want us to find the domain, right? And maybe you noticed this doing the homework last night. Maybe you didn't notice this doing the homework last night. If you didn't, okay. If you did, good job. But if the domain of this person is the reals and the domain of this person is the reals, then when we do step one, we're going to have no issues. And when we do step two, we're going to have no issues. So then the domain of the composition is always going to be the reals. That's one of the things that Mr. Sullivan was hoping you noticed doing the homework last night, right? That's one of those things that he was hoping you noticed. I didn't make a big deal out of it when I talked to you on Monday, because I was going to, I was hoping you'd notice it yourself as well. If we look at G composed with G, right, our first step is to find the domain of G. Right, that's step one. We always find the domain of whoever is inside. Well, G is a polynomial. So the domain of G is all reals. Then step two for us, right, is our step. Right, here we have to ponder. And we start with, does this function over here, right, that's function number two, does it have any issues? For us, that's the question, does G have any issues? Now, we already answered that question. We answered it right here. The answer is no. G has no issues. So this is G in the picture we're doing, right? We're doing G and G. We have G and G. Well, X can be anybody. G of X can be anybody. So our domain then is going to be the reals. Now, that's not always going to be the case. We're going to do a problem here in a second where it's probably not the case. Problem 37 probably doesn't work out like that. But problem 33 did. Okay. So let me erase this. See if we have a... So we'll do problem 37 now, right? So problem 37, we have different functions now. Now we have f of x equals x over x minus 1. So this is going to be more complicated because f's going to have issues. And we have g of x is negative 4 over x. G has issues. All right, so we're going to think a little more for this one. Now, if we do part B, right? Because I did part A on the last one, so I'll do part B here. Part B says find G of f. Now we know what that means. That means G goes second, F goes first. Right? That's what we're going to deal with here. And they want us to find the domain of this, right? They want us to find the domain. And they want us to find this. So I'm going to do the same thing I did before. I like to warm up. So I go over here and I find G of 2. And that's going to be negative 4 over 2. Negative 2. And I find G of 8. And that's going to be negative 4 over 8. That's negative 1/2. And then I find G of P. And that's going to be negative 4 over P. All right, I can't do anything with that. And now when I find g of f, it's going to be -4 over f, because that's what we do. I mean, I apologize for having to warm up, but I flunked calculus twice. So, you know, I got a C- in pre-cal. But this helped me figure out how to do it. So that's why I do this. Now, what does that mean? That means we get -4 over, and now we're going to put x right here. So we get this. Now, that's not anything to panic about, right? We're supposed to know all the rules about complex fractions right now. We're supposed to know all of the rules. Like, for example, rule number 1, right? If you have a fraction divided by a fraction, you invert the denominator and you multiply. Right? We're supposed to know that rule, right? That's not supposed to be like, I wonder what to do here. We're supposed to know that rule. I mean, after all, we learned this in like 4th grade. If you have a fraction on the top and a number on the bottom, we're supposed to know what to do. Right? We're supposed to know what to do. We're supposed to know, hey, this is a fraction too. All right. And now we use the rule from here. So we're supposed to know that rule. I mean, we're supposed to know. Like when somebody writes this down, right? We're not supposed to be confused. And if we are, we need to fix that. We need to put this on a note card and fix it. Because, I mean, come on now. It's been like 6 years. We're supposed to know the numerator of the denominator is a denominator. So I'll say the words again. We're supposed to know that, right? That's not supposed to be something we're stuck on. We're supposed to know that the denominator, right? Because this is under AB, so I'm calling it the denominator. The denominator's numerator is a denominator. We're supposed to know that. I mean, we've seen this. You guys have seen this hundreds of times. We're not supposed to be stumped by these things anymore. And then the other case is we have a number on the top and we have a fraction on the bottom. And then what do? We write this like this, a over 1. And then we use this rule again. And you know, funny thing happened. Look, funny thing happened. The numerator of the denominator turned out to be a denominator again. No, that's because it happens every time. The numerator of the denominator is the denominator. Yes. Yes. I know that's a lot of words, but come on now. You're a lot of student. We're not supposed to be stumped by this, right? We're supposed to be able to go like this. This is -4 times x minus 1 divided by f. That's what we're supposed to be able to do. At this point in our lives, that's what we're supposed to be able to do. Not go, oh God, what am I going to do here? What am I going to do? No, you're not supposed to do that. You're supposed to know these rules. And think of how much nicer your life would be if you did, right? I mean, then you wouldn't panic over this anymore. Now, we can talk about why it turns out like that. I mean, I showed you right here, but there's a lot of things you can do here to solve this, right? You can think, well, I want this fraction to go away, so I'm going to multiply down here by x minus 1. Of course, if I multiply down here by x minus 1, I've got to multiply up here by x minus 1. I mean, this is one way you can solve this. Right? And if you do that, what do you get? You get -4 times x minus 1. And down here, the x minus 1s go, and you know, funny thing, you get the green thing again. Well, of course, you're going to get the green thing. You're going to get the green thing every time because you're going to get it right. So that's one way you can do it. You can multiply to get rid of the common denominator. Another way you could do the problem, if you don't like that way, and you don't want to memorize these, right? Another way you could do the problem is you could start here. And you could go, well, that's not really a -4. That's really 4 divided by 1. And then you could go, well, that's -4 divided by 1 times x minus 1 over x, right? And this rule right here. And you get the green problem again. And you get the green answer. We're not supposed to be doing this work anymore, is what I'm trying to get you to realize. We're supposed to be able to do this in our head by now, right? We took all of elementary school, and then we took pre-algebra, where they taught us this. This is pre-algebra, by the way, in case you don't understand. This is not algebra 2. And then we took algebra, where we used this. Then we took algebra 2, where we used this. So at this point, we're supposed to have this, right? Here's the truth. Most pre-calc students don't have this. But when they're in pre-calc, most students go, you know, I'm really tired of being mystified by how to do these. I probably just need to memorize these rules. There you go. Welcome to the grown-up world. Because we don't want to be stumped by this anymore. We don't want to be stumped by this anymore. We've been stumped by this so many times. Let's just figure it out. I proved it to you right here. Right? So the denominator's numerator, right? Let's circle them. The denominator's numerator turns out to be a denominator. Yep. That's true. The denominator's numerator turns out to be a denominator. Yes. And the denominator's denominator turns out to be a numerator. Yes. There you go. That's exactly what happens. And if you know that, you don't have to worry anymore about these fractions. And wouldn't life be really special if we didn't have to miss these anymore? I mean, that would really make things good, right? We get them all right. Because that's what we're shooting for here. So that's G composed with F. But now we have to find the domain, right? We got to define the domain. And we'll do this one. We'll do this one with the pictures, in case you're tired of me writing out the steps. We'll do one with the pictures. Maybe people are more picture oriented. Now remember, this is my first function, right? That's f of x in this case, because that's on the inside. This is g of x over here. Now x goes in here, right? G of x goes in here. Sorry, my bad. F of x goes in here, right? Okay. Now this is exactly the same as the steps, but we just do it with a picture. We still start with what's the domain of the inside function, right? What's the domain of this? What's the domain? Does x have any problems? What issues does f have? And we look up here and we're like, well, you can't have a 1. You can't have a 1. So we write that right here. We say, well, we can't have 1. Okay, we write that right there. And I think on Monday I told you, I like to put a circle around it so I don't lose it. Now we go over here and we ask ourselves, does G have any issues? Does G have any issues? And we look up here and we're like, oh yeah, G cannot handle 1. No, sorry, 0. G cannot handle 0. G can't, you plug in a 0, bad things happen. So we say, okay, this is what we're plugging in. That can't be 0. Now we always have to solve that, right? That always gives us something we have to solve. So we have to solve that. So f of x is x over x minus 1. That cannot be 0. We multiply both sides by x minus 1. Right? That's how you clear the fraction. This side's still x, of course. Over here, when you multiply 0 by x minus 1, you get 0. There we go. So now we have our 2 restrictions. what we call it, right? Our two limitations, our two issues. So now we can write the domain of this, right? We can write the domain. We say the domain of G composed with F is going to be the set of x's such that x cannot be 0 and x cannot equal 1. But if we would have looked at this, we would have only picked out 0. So we did part B. I did part D on 33. So I'll do part C, right? We'll do part C. Get rid of this. We don't need any pre-algebra on the board anyway. It's kind of embarrassing. You guys can all master those rules. Come on now. You mastered your sevens, right? Sevens are hard. I mean, 7 times 1, everybody's good at that one. 7 times 2, we're good at that one. 7 times 8, I mean, 50, man, that's hard. And you mastered that when you were 8. 7 times 9, those are hard. The sevens were tough. For some of us, I mean, for me, they were tough. So what does part C want us to do in 37? It wants us to find f of f, right? F of f. Now we know what that means. Now I'm going to warm up because I got to warm up. I'm going to find f of 2, and that's going to be 2 over 2 minus 1. And then I'm going to find f of 7, and that's going to be 7 over 7 minus 1. And then I'm going to find f of w, and that's going to be w over w minus 1. And now I'm ready to find f of f, because that's going to be f over f minus 1. The warming up thing really does help. Now I know what f is. I know what f is. F is x over x minus 1. So this thing turns into x over x minus 1 over x over x minus 1 minus 1. That's not good. All right? I mean, that's borderline unfair. No, we're gonna have to do algebra. Right? We gotta simplify this. That's the first thing we have to do is simplify that. All right, so we leave the top alone. We need a common denominator here, right? This person's denominator is 1. So our common denominator is going to be 1 times x minus 1. X minus 1 is already here, so we don't change anything, so we just get x minus. There's a 1 up there, so I have a 1. And then I have to multiply x minus 1, so I get this. And I'm not going to panic or anything. I'm just going to keep writing. The top, I haven't touched the top. It's x over x minus 1. We haven't got to that yet. The bottom, down here, I have x, right? I have minus 1 times x. That's minus x. I have minus 1 times 1. Sorry, I have minus 1 times minus 1, so that's 1 over x minus 1. Now I still have the top. These cancel, and I have 1 over x minus 1. Now, that's a fraction, right? That looks like this. I mean, look, the denominators are equal. I mean, the denominators are the same thing. So it looks like this, BB. Well, we all know what that's going to be, right? This B is going to cancel this B. Because another rule we need to know, right, about fractions is denominators cancel denominators. numerators cancel numerators. I mean, this is gold. I hope you're writing this stuff down. Denominators cancel denominators. We're not supposed to invert and multiply that, not in pre-calc. Now, if it takes us inverting and multiplying it to get the right answer, well then darn it, we're going to invert and multiply it. But we want to get away from that. And we want to move off that. Denominators cancel denominators. I mean, look at the picture. By the way, numerators cancel numerators, but we don't have any common factors, right? So what do we get here? We get x over 1. We get x. Now we have to find the domain. The inside function is f, so that goes first. The outside function is f, so that goes second. Does this have any issues, right? That's our question. And then our next question is, does f of x have any issues? Those are our two questions. Just like over here, those are our two questions. Just like we wrote down in problem 33, we wrote the questions down in problem 33. So we ask ourselves, does f of x have any issues? And we look, right? We look at f of x. Okay, can't have one. Can't have one. So that goes right here. Can't have one. And then just like over here, right? Just like over here, we looked at g of x and we said g of x can't have 0. So we wrote not equal to 0. Right over here, we have f of x in here. So we look at f of x, well, can't have 1. So right here, we write f of x cannot equal 1. Now, we have to solve that, right? We have to solve it. You always have to solve step 2. If there's a step 2 that's got an issue, you have to solve that. We have to solve that. So we need to clear some space. So let's erase some things over here. Step two is the working step, right? I mean, that's the step. It's not like, you know, cotton candy, yummy, yummy. It's like I got to ponder this. I have to think this through. So we have f of x can't be 1. Now we know what f of x is. That's this. We multiply both sides, right? We move the x over here. Well, that's false. Well, let's rephrase. That's always true. I mean, come on, 0 is never equal to -1. What does that mean? That means this can't happen. We don't have to worry about that. It's never going to happen. F of x can't equal 1. This fraction never equals 1. You all know that never equals 1. You all know what the graph of that looks like. Everybody in the room can graph that. Everybody knows, oh, let's see. First thing I got is I got a vertical asymptote at 1. Hey, I bet x is never going to be 1. Oh, hey, x is never going to be, it's never going to be 1. Yeah, your function can't be 1. There's a vertical asymptote there. If you would have thought about that, you wouldn't even have to do this step. It's okay that you didn't, because we're learning the steps. So this doesn't give us anything. So our domain is just x can't be 1. It's good to think. Thinking's good. Thinking's good. It makes our brain stronger when we use it.
Mr. Rainier,
Yeah, go ahead.
could you do the domain part the other method? Because
Yeah, steps.
Yeah.
Yeah. Let me erase some stuff.
Thank you.
don't forget, f of x was x over x minus 1, right? And we were finding f composed with f, which we said was f on the outside, and as it turns out, f on the inside as well. So step 1, find the domain of the inside function. I'll write it as inside function this time, so it's more, it's more clear to them. So inside is f of x, right? So f of x is x over x minus 1. So the domain of that is x can't be 1, right? Now that's it for step 1. Step 2 is our step. Now we start with, right? We start with a question. Does the outside function have any issues? Not does. And we write, yeah, it does. I mean, the outside function is f. F has issues. F cannot handle 1. Right? You can't plug in a 1. You're not allowed to plug in a 1. So what we then said was, right? What we said was, so the inside function cannot be 1. Now, our inside function is x over x minus 1. That can't be 1. It can't be 1. And now if we do our algebra, right, we multiply both sides by this, and we get x cannot be x minus 1, right, because this times 1 is itself. We bring the x over here, negative x, we get 0 cannot equal 1. That's always true. I mean, I think we all agree 0 is not 1. Sorry, negative 1. So what does that mean? There's no restrictions down here. So our only restriction, remember how we answer our question when we're doing the 2 steps, we take the restriction we found in the first step and any restriction from the second step and we combine them. Well, we don't have a second step restriction. So our domain of f composed with f is just the restriction from up here because there were no restrictions down here. Let me get this.
Okay, thank you. It makes more sense.
So that was 33 and 37. 53 is up there twice. I didn't notice that before, but 53 is up there twice. I'm only going to do it once. I mean, unless I get it wrong, which could happen, let's be honest. Then we'll end up doing it twice. So 53 says, find 2 functions that go together to make our function. So we have capital H of x is 2x plus 3 to the 4th power. And it says to find me 2 functions, f and g. And they want it so that g I do first, f I do second, because g is on the inside. Bless you. Ms. Rainier sneezed. So I yelled bless you because she could hear me through the floor. So yeah, it says f composed with g. So g we do first, f we do second. Now the way you do these decomposition problems is you do this. You're like, I'm going to find h is 7. Okay, I'm gonna find h of 7. And then you ask yourself, what am I gonna do? Right? What am I gonna do? Because we're all very good at finding h of 7. We all know what we're gonna do. We're gonna put a 7 right there. And then we're gonna add 3. I mean, that's what we're gonna do first. We're not gonna raise it to the 4th power first. The 4th power comes after we do what's inside. So whatever you do first, that's your first function. So my first step is to multiply by 2 and add 3. So my first step is to multiply by 2 and add 3. So I write 2x plus 3. Now, we all know what that gives us, right? That gives us 17, right? 17, 14 plus 3. So that would give us 17. After we get to 17, then we raise it to the 4th power. So my second step would be raising it to the 4th power. And there we go. Done. And that's how you do it. You just plug a number in and you ask yourself, what order would I do this in? And what would I do at each step? And if some of you are thinking, well, you did 3 steps, I fully agree with you that I did 3 steps. But your author said to make it a 2-step problem. See, personally, I think it's a 3-step problem, right? I don't think I don't think this is a 2-step problem. I think it's a 3-step problem. Step 1 is multiply it by 2. I mean, that's the first thing we did. Because we really combined 2 steps. We multiplied and we added at the same time. That's 2 steps. Now, the second step, right? The second step is to add 3. Okay, take your answer. Add 3. Don't put a 2x there. We already did the times 2. You did the times 2 down here. Don't put a 2 up there. Now you're multiplying by 2 again. And then the last thing we did was raise it to the 4th power. Those take practice for your brain to start going backwards, right? For our brains to go backwards, we have to practice. We didn't all start walking on a Tuesday and start walking backwards on Wednesday. It doesn't work like that. Backwards takes more practice. But if we can do it backwards, we're really good going forward. So I skipped 41. So let me do 41. I didn't mean to skip 41. It wasn't on purpose. 41 is a good prime number. I don't know why I skipped it. Nothing against 41. Big fan of the prime numbers personally, so. Not a big enough fan to study them in grad school. Don't get wrong with you. I'm an applied mathematician. That's theoretical math. I don't like theoretical math. I like applied math. What can I do with math? Not let's just talk about math because it's a Wednesday. So what are we doing in problem 41? Well, in 41 we have an f of x, and it's x squared plus 1. Now we like that, right? We're big fans of that. By the time we got to 41 last night in the homework, we were supposed to look at 41 and go, whoa, yay. Why? No restrictions. Right? There's no restrictions on that. That's good. We like that. G of x is the square root of x minus 1. Restrictions, right? Can't have a negative under there because that's an even root. So let's find g of f. I don't even know what part that is. A, B, C, B. Let's do that. So what are we going to find? Well, we're going to take G and we're going to put F inside that, right? That's what we're going to do. We're going to put F inside that. Now, I'm going to warm up. If I find g of 2, that's the square root of 2 minus 1. Find g of 8, that's the square root of 8 minus 1. If I find g of q, that's the square root of q minus 1. So g of f of x is the square root of f of x minus 1. I appreciate you, by the way, you not mocking me for my need to warm up. I do appreciate that. Now we know what f of x is. We can simplify that. And we know what that is, because Mr. Rainier taught us that on the first day of school. It's not x. It's not x. It's not x. It's the absolute value of x. Because what? Well, because if I ask you to find this, that's x. And no one's going to write this down for an answer. When you take the square root of something squared, they don't go away. Because if they go away, you're going to tell me that the square root of -4 squared, which all of us know -4 times -4 is 16. And we all know the square root of 16 is 4 because our calculator says that every time we put it in. You would instead tell me that it's -4, and we know that's wrong. So this is the absolute value of x. We don't want to mess that up. He put this problem in the book so I could talk to you about this again. That's why it's here. To remind you, because we haven't talked about it in a while. It's November, right? December now, pardon me. So he stuck it in the book so we could talk about it again. I mean, he writes a very good book. Right? He knows you forgot that, or maybe it slipped your mind, or maybe you learned it really well the first time and you remember it. But some of us forgot it. Now we have to find the domain. Step 1. Find the domain of f, right? That's our inside function. Well, that's a polynomial. That's everybody, right? We noticed that when we were writing it down. When we were writing it down, we're like, yay. Step 2. Well, we start with, does g of x have any issues? And the answer is yes. Yes. X minus 1 has to be greater than or equal to 0. I mean, that's true, right? You can't put a negative under there. Remember I said we don't say x minus 1 cannot be negative. We don't say that. We don't do that with inequalities. We go the other way and we take the yes part instead of the no part with inequality. So we don't use the not part with inequalities like we do not equal. Now we all know what that means. That means x has to be greater than. Well, that's not our problem, right? That's not our problem because our problem isn't x. Our problem is we're not worried about x. We're worried about f of x. Right? Because that's who's underneath here. That's what we said, right? We said, does g have any issues? Yes. G, this is why we write it in words, cannot handle numbers less than 1. The reason we write it in words is so we don't write down what I just wrote down on the paper right there, which was x. And then we solve that and we think we're done. That's not what we're trying to solve. G can't handle numbers less than 1. So f of x has to be greater than or equal to 1. F of x has to be bigger than or equal to 1. right? F of x has to be bigger than or equal to 1. Well, what's f of x? F of x is x squared plus 1 has to be bigger than or equal to 1. I'm just taking it over here. You know, a funny thing about x squared plus 1? It's a parabola. Opens up. This is 1. Funny thing about that parabola, it's always bigger than or equal to 1. I mean, look at the graph. It's always bigger than or equal to 1. This is always true. So we don't have any issues. Right? Step 2 didn't give me any issues. Step 1 didn't give me any issues. So the domain of G composed with G is everybody. Because I don't have any issues from step 1. I don't have any issues from step 2. So I don't have any issues at all. So I get everybody. That's how we find the domain. So let's talk about what happens after this.
Wait, Mr. Rainier,
Yeah, go ahead.
can you explain that one more time? Because I'm still a little bit confused on how it's all the reals, but you can't have numbers less than 1.
Okay, hold on. Listen to what you said. You said you can't have numbers less than 1. But what we wrote is we can't have f of x's less than 1. Right? Because G isn't getting, think about our picture now. Think about our picture. Right? Think about our picture. F is here, G is here, right? Is everybody okay with that? F comes first, right? The numbers, the x's go in here, don't they? That's where the x's go. Those are our numbers. That's where they go. They go into F. Who goes into G? Not our numbers. Our numbers don't go into G. Our f of x's go into G. Right? Not our numbers. If you give me an 8, 8 doesn't go into G. If you give me an 8, 65 goes into G. Right? Because if you give me an 8, 8 starts here. Here's where 8 starts. Hi, I'm 8. Nice to meet you. Oh, nice to meet you too. 8 goes into here, turns into 65, right? 8 squared plus 1 turns into 65. G gets 65. G doesn't get 8. What happens if I plug in -3? Well, G doesn't care. Because what happens if you plug in -3? Well, the very first thing that happens when you plug in -3 is it goes in F first. If you plug in -3, you get 9 plus 1. 10 goes into G. Not -3. -3 goes into F first, right? F is our inside function. -3 goes into it first. The answer from F goes into G. Well, look at the picture. F never gives us answers that are negative. You give me an X, it gives me a positive. You give me another X, it gives me a positive. You give me a negative X, it gives me a positive. You give me a negative X, it gives me a positive. You give me 0, it gives me a positive. So it's never going to break the square root because it's never going to give us a negative. And it always gives me somebody bigger than 1. So be careful. The numbers go into the first function. The output of the first function goes into the second function. That's why we write it in 2 steps.
Okay, thank you.
I don't know if that helped at all, but I tried. All right, so let's talk about the next section. Right? What happens? I'm having to hold the whiteboard cleaner perfectly flat on the whiteboard so that the little bit of whiteboard cleaner on the bottom gets sucked up by the straw and spit out on the whiteboard. I'm that cheap, in case you're wondering. One of the ways that you accumulate wealth is you don't spend your money. It's one of the hardest things to explain to your clients when you're an accountant. What do I need to do so I could retire sooner? Stop spending your money. Okay, what else can I do so that I can retire sooner? Win the lottery. Okay, well, that's not going to happen. I agree. Okay, so what else can I stop spending your money? I mean, it just, we kind of cycle back to that one all the time. All right. 5.2. One-to-one and inverse functions. Okay. So we're going to start with the definition that we learned in Algebra 1. Now, we may or may not remember the definition. Who knows? It says a function is a one-to-one function. And then he writes the most wackadoodle definition of a one-to-one function I've ever seen in my life. So I'm not going to use it. I don't use it because it's wackadoodle. A function is a one-to-one function if, right? If every range element corresponds to only one domain element. That's a good definition. Okay, that's a good definition. That's not wackadoodle like the one he puts in the book. Now, what does that mean? Okay, let's draw a picture. Pictures worth 1,000 words. Okay, let's talk about Algebra 1. In Algebra 1, you had a teacher, I hope, and they said, if this is A, and this is B, and this is C, A turns into 1. Let's just make it turn into 1. B turns into 4, because you thought I was going to write 2, so I wrote a 4. C turns into 4. This is a function. All of you know it's a function. This passes the vertical line test. This is a very boring function. This is the entire function. That's it. That's the whole function. It's boring. It has 3 points. If you're going to graph this function, it has 3 points. I mean, if you're going to draw the graph, right? If you can draw the graph of this function, it's got 3 dots. That's it. 3 dots. Here's A. Why is that A? Because I got the pin and I got to say that's A. And when you plug in A, you land at 1. Okay. There's part of your function. Here's B. Why is that? Because again, I got the pin. When you plug in B, you land at 4. Here's C. When you plug in C, you land at 4. I think that passes the vertical line test. I think every one of us knows that passes the vertical line test. So it's a very boring function. It has 3 dots. But it's a function. Because what our teacher told us in algebra was every x can only go to 1, 1. That's what our teacher said. Every x can only go to 1, 1. That's what they said. This x goes to 1, 1. This x goes to 1, 1. This x goes to 1, 1. Nobody said you couldn't go to the same y. Your teacher didn't say that. They said every x goes to 1, 1. Okay, so this is a function. This is not a one-to-one function. See, to be a one-to-one function, every range element has to correspond to only one domain element. In other words, every y goes to only one x. We add a condition for one-to-one functions. Oh, we still have the other condition. It's still there. Every x can only go to only one y. Every x can only go to one y. That's still a condition, see? Because look at this word right here. Look at this word right here. You're starting with a function. You're starting with a function. So every x can only go to one y because it's already a function. And now we add a second condition. That's why I don't like his wackadoodle definition. It doesn't call attention to the second definition. We add a second definition. We go, well, you know what? See how this person can only go one way? This person can only go to one. This person can only go to one. Well, now we're going to put that rule on the range. We're going to tell the range, hey, same rule for you, bro. Only one. So this is not a one-to-one function because this person goes to one, this person goes to two. Can't have that. Not one-to-one. So when we look at the graph, we're like, it's not one-to-one. And the reason it's not one-to-one is they told us this in Algebra 1, and then they told us again in Algebra 2. They told us one-to-one functions must pass the horizontal line test. That's what they said. They gave us a new test, a different one. They gave us that rule. They said you got to pass it. Well, this doesn't pass the horizontal line test. Let's see. Yep, only hits one dot. No, hits two dots. Doesn't pass. So in your homework, they're going to draw pictures of functions. And they're going to ask you, is this a one-to-one function or not? You are literally going to have homework problems where you draw horizontal and vertical lines. They're just going to draw things, all right? They're going to go, hey, here's your friend, the square root. Is this a one-to-one function? And you're going to go, well, let me check, Bill. Let me look into that for you there. Well, first of all, it's a function. You always want to check that first because they trick you. They do. They trick you. And like question 12, they always trick you. And then you're like, passes the yep, one-to-one. Pass both tests. Both tests. You heard what I said? Both tests. Because, then they give you this one, and you're like, oh, no way, dude. No, not gonna happen. It's a function. Yep, she's a function. Look at her. There, she's beautiful. She's a function. Passes the vertical line test. Function? Yes. One-to-one function? No. Not a one-to-one function. Hits it twice. If you draw a horizontal line instead of that one, which was like 75 degrees off. Not a one-to-one function. Then this is what they sneak in on question 12. Question 12, they always do this. They always sneak this in on question 12. And then you go like this. You're like, oh, yeah, look at that. Pass the horizontal line test, one-to-one function. We all know that's wrong. It's not even a function. How can it be a one-to-one function if it's not a function? You can't have a purple giraffe if you start with an elephant. Right? I mean, you can't. Is that a purple giraffe? Yes, it is. No, it's not. It's a purple elephant. Well, I only looked at purple. Yeah, it doesn't work. Logic doesn't work like that. So they always sneak this question in. It's going to be in there somewhere. Don't worry about it, or something like this. Don't fall for it. You're smarter than that. And you're way smarter than that. Don't fall for that. Where do we go from here? Well, this is all algebra 2, by the way, in case you're wondering. In case you're thinking, I saw this last year. Yeah, it's because, you already learned about one-to-one functions and inverse functions, and there's really nothing new about them for me to teach you. From last year to this year, there was a pandemic. I don't know if you heard, but that's about all that's happened. So how do we find the inverse? Okay. That's a good question. All right. There were some steps last year, right? Remember those? How to find the inverse? There were steps. We like these problems in algebra 2 because there were steps. Steps are good. I like steps. Step 1, set f of x equal to y. I'm just going to write the steps down. Step 2, switch x and y. Step 3, solve for y. Step 4, call y f inverse of x. Those were our steps. Okay, those were our steps. So if they give us a function like this, right? And they ask us to find the inverse. It wants to find the inverse. We just follow the steps. Good. Good. I mean, it's not very complicated. I mean, it was in your Algebra 1 book, so it can't be that hard, right? Step 3, solve for y. Okay, so we go x times y plus 2 equals 1, right? Multiply over here, cross multiply. xy plus 2x equals 1. Now, distributive property. Very good. Good job. I'll move that over there. I think that's a good plan. I'm going to divide by x. I like that. I like that call. Good call. Step 4, call y f inverse. Done. I mean, come on, it's algebra 1. Now, the real important question, right, is why are we doing this? I mean, I haven't even told you what an inverse is. I just said it's this thing you go find. Right? Why do we care? Why do we care what it is? Well, let's ask ourselves this. What is f of -1? All right, here's that. I think we can all do this, right? I skipped some steps. I'm sorry. I apologize for that. That's going to be a 1/1, which is 1. So if we look at a picture, right? If we look at a picture, here's f, here's our function. This is our domain. This is our range, right? If we have -1 here, right? -1, it lands on 1. That's what our function does. It turns -1 into 1. Or on the graph, right, it goes through -1, 1. Well, f inverse is just the function that goes back the other way. That's f inverse. That's what f inverse is. It's the function that undoes what f did. What did f do? It messed it up. Don't worry about it. F inverse will fix it. It'll turn it right back. So let's find out what's f inverse of 1. I mean, I'm claiming it's going to be -1, right? That's what inverses do. Well, let's put a 1 in here and see what we get. We get 1 minus 2 times 1 all over 1. That's going to be 1 minus 2 all over 1. That's going to be negative 1 over 1, which is going to be negative. You know what it did? It turned it right back into negative 1. That's what inverses do. They undo whatever the function did. Inverses, you wrote that down, right? You probably already remember that from Algebra 1. Inverse functions undo what the function does. That's what inverses do. They undo what a function does. Now, a real logical question would be, so what? Who cares? Question. That would be a real logical question. It would be a question that I think an honor student would ask. And I don't mean that sarcastically, I mean that seriously. It's like, why do I care? I mean, think about it. Instead of undoing what the function just did, why do I just go with this route? I won't use the function, and then I don't have to undo anything in the first place. I mean, that's what I thought when I was learning about inverse functions. The teacher was like, well, you know, the inverse function undoes what the function does. There you go. That's what you need. It undoes it. And I literally raised my hand in class and went, well, why don't we just not use the function in the first place? And they're like, what do you mean? And I go, if we don't use the function, it never changes it. And now we don't have to change it back. It seemed perfectly logical to me. Mr. Mert didn't appreciate that question. I'll be honest with you. I didn't earn any brownie points from Mr. Mert for that question. So here's why we have inverse functions. Because this is what I wanted to know, right? I was like you. I was inquisitive. I was smart. I wanted to understand. I get it. I see the 4 steps. I can do the algebra. Come on, man. I've been doing that since Algebra 1. I took that class 3 times. I've got that. Why do we care? Why do we care? I mean, that's what I want to know. Why? Here's why you care. Right? This is a function. The domain's where we start. The range is where we end. Right? This is what we do with functions, right? We find a domain. And then let's not lie to anybody. They ask us that question nobody wants to get. What's the range? We don't want to know the range. We can all find the domain. Everybody can find domains. We did it last night in homework for composite functions. We can find domains. Finding the domain is not hard. Finding the range sucks. It's not fun. Nobody wants to do it. One way to find the range is to draw the graph. We don't like to do that. I don't fault you for that. You know, here's a weird thing though. Inverse functions go this way. Which means this is the domain of F inverse. So when somebody asks me to find the range, I just find the domain of F inverse because I'm really good at domains. Now I don't have to draw the graph. You want the range? Give me a second. Hang on a second. Wait, just chill. Let me find the inverse. I'm really good at domains. I'm going to find the domain of F inverse. You know what that's going to be? That's going to be your range. And finding the range of F inverse, let's be honest, that's not very hard. We already found it. It's the domain of F. See, that's why we have inverse functions. So we can find this without having to do all the work. And that's what inverse functions are about. Inverse functions are about finding range. That's the real reason we have them. Because in the real world, that's what we do with them. Now, in geometry and in algebra 2 and in algebra 1, they taught you something about the graph, right? They said the graphs of a one-to-one function f and its inverse are symmetric. There's that word again, right? With respect to the line y equals x. That's what they taught us in algebra 1 and algebra 2 and geometry. They actually talked about that in geometry. Notice it's not the origin, it's not the x-axis, it's not the y-axis. We're not in chapter 1 anymore here, Dorothy. So if you want to draw the graph of f inverse, all you do is reflect your graph across that line. That's it. That's all you do. And then you're done. And we can all reflect. We all know how to reflect, right? We all know what to do. We all know what to do. If you're going to reflect that point across there. In geometry, they said, draw perpendicular from your point through the line. And we all know how to do that. Then make sure this segment and this segment are congruent. And we all know how to do that. And then the coordinates of this point is going to be 1, 3. That's what they told us in geometry, right? Perpendicular, bisector, constructions with compasses. It was good times. All we do in algebra is this. Right? I mean, that's all we're going to do. We just switch x and y. Isn't that one of the steps? Isn't that step 3? Step 2. It's step 2, right? Step 2. Step 2. Can we write that as step 2? Switch x and y. 3, 1 becomes 1, 3. I mean, it's not very hard. All right. You're ready for the homework. So what are we going to do for homework? You know, there's like 700 problems in here. I mean, okay, there's 103 problems. We're not doing all this. We're not going to do this. We're going to do 1 through, okay. We're going to do 3 through 72 multiples of 3. All right, so it's section 5.2. But we just need multiples of 3. We don't need to do all the odds. I mean, that's way too many problems. All right. Thanks for hanging out with me today. Everybody have a good time. And we will, you know, when do we get back together?